Hello students, today in this video we'll see how selection sort works. But before learning selection sort, let me tell you what is sorting. Sorting is the process of arranging the elements of an array so that they can be placed either in ascending or descending. So ascending is arrangement of elements from smallest to largest, and descending is arrangement of elements from largest to smallest. For example, if there is an array A, and if A1, A2, A3, A4, An are the elements of array, then ascending order is that A1 is the smallest in the list and An is the largest in the list. Here there is an example. Here there are some elements in the array 77, 42, 35, 12, 1015. So if this array is to be sorted, then it will look like 5, 12, 35, 42, 77 and 10. That means this array is sorted in ascending order. If it is descending, then exactly opposite of this. 101 will be the first element and 5 will be the last element. Now there are two techniques by which you can do sorting. First one is internal sorting. So internal sorting is nothing but the data on which you are doing sorting is placed in a main memory. It is readily available in the main memory. So such type of sorting is called as internal. And another is external sorting, where the data on which you are applying sort is not available in main memory. It is stored into some secondary storage devices like hard disk, CD, pen drive. So what happens in case of external sorting, you need to transfer this data from the secondary storage devices to main memory. So it will require some extra amount of time. That's why internal sorting is called as the fastest technique, because the data need not to be transferred, it is available in the main memory. And in external sorting, data is to be transferred from secondary storage to main memory. Now today we have to discuss all internal sorting techniques. So sorting is done by the technique called bubble sort, selection sort, insertion sort, shell sort, radix sort, merge sort, quick sort and heap sort. So these are some internal sorting technique. Today we have to discuss selection sort. What happens in selection sort? Selection sort sort, or we can say, places the smallest value among the unsorted elements of the array. That means the smallest value in the array is placed at its appropriate position. First, it find the smallest element of the array and place it to the first position. Then find the second smallest element of the array and place it to second position. So this process continues till we get the sorted array. So smallest element from the array is selected and placed to its appropriate position. That's why the name of the sort is given as selection sort. Let's see how it works. For example, this is an array, contains 5 elements, 23, 9, 4, 45 and 27. So the n is nothing but 5. So this is the placing of elements in the array, 23, 9, 4, 45 and 27. So here we will discuss the ascending sort process. So first of all, the first element is compared with the second element. So 23 is compared with 9. This element is out of order. 9 is smallest and 23 is the largest. So shifting is done. So 9 and 23 is shifted. After that, again the first element is compared with the third element, 9 and 4. Again there is a need of shifting of element, interchanging the position, because 9 is greater and 4 is smaller. So the element is shifted. Again the first element is compared with the fourth one, 9 and 45. 4 and 45, sorry. So there is no need of shifting over here because 4 is already smaller. Again in the next iteration, first element is compared with the fifth element, 4 and 27. So again there is no need of shifting over here because 4 is already smaller and 27 is larger. So at the end of first pass, the smallest element of the array is placed at the first position in selection sort. So here you can see that 4 is nothing but the smallest element from the array, so it is placed at the first position. So here in every pass we have to count the number of comparison and number of exchanges. So here in pass 1 there are 4 comparison and 2 exchanges. Now let us go to pass 2. In pass 2, as first element is already to its appropriate position, so there will be no comparison from the first element. So here second element is compared with the third one. So 23 and 9. So 23 is greater, 9 is smaller. So there is a shifting. So 9 and 23 is shifted accordingly. Now again second element is compared with the fourth one, 9 and 45. Now here there is no need of shifting because 9 is already smaller. Now in the next iteration, again the second element is compared with the fifth one, 9 and 27. Again there is no need of shifting because 9 is smaller. So here in at the end of second pass, you will observe the second largest element, or I can say the second smallest element, not largest. Second smallest element is placed at the second position. So how many passes are required? If there are 5 elements in the array, then you will require 4 passes. If there are n elements in the array, then n minus 1 pass are required in selection sort for the sorting. Again in pass 3, third element is compared with 4, 20 and 45. There is no need of shifting. Again third element is compared with fifth, 27 and 23 and 27. Again in both the cases there are only comparison, there is no need of shifting because 23 is lesser than 45, 23 is lesser than 27. So you can, here at the end of pass 3 you can see that the third smallest element in the array is placed at the third position. Now let us go to the next pass. In next pass, fourth element is compared with the fifth, 45 and 27. Now here there is a shifting because 45 is the largest and 27 is the smallest. So 27 and 45 are interchanged with the values. At the end of pass 4, here you will see that the array is sorted. So as I said earlier, if there are 5 numbers in the array, then you are going to require 4 passes. So here at the end, find out total number of comparison, total number of exchanges and total number of passes required. This is the algorithm. We have to use nested for loop for it. I and j. So here the outer for loop rotates from 0 to n minus 1 and j for loop rotates from I plus 1 to n minus 1. Now here compare, if a of I is greater than a of j, then swap a of I, a of j accordingly. The worst case time complexity of this selection sort is big O n square. Here we will take one more example. There are 7 elements in the array, 40, 20, 70, 10, 92 and 54. Here you can see that the first element is compared with the second one. So here in first pass, every time first element is compared with all further elements, and if there is a need of shifting, the elements are shifted. And at the end of the pass, you will get the smallest element placed at the first position. In second pass, second element is compared with all the elements of the list, and at the end of the pass, the second smallest element is placed at the second position. In pass 3, third element is compared with all, and at the end of pass, third smallest element is placed at the third position. In pass 4, fourth element is compared with all, and at the end of the pass 4, fourth smallest element is placed at the fourth position. In pass 5, fifth element is compared with all. In sixth pass, sixth element is compared with all. So there are 7 elements in the array, that means we are going to require 6 passes. So at the end, you need to do this analysis, number of passes, number of comparison and number of exchanges. Thank you.